Hello, today we'll be solving transportation problem. In this problem we have three sources A, B and C. The source A can supply maximum 100 units, B can supply 30 units and C can supply 70 units. And we have four destinations 1, 2, 3 and 4, each having demands of 40, 20, 60 and 30 respectively. The profit incurred while a source transfers some unit to a destination is also listed in this matrix. So how do you solve this question? The purpose of solving the question is to maximize profit. Okay. So first of all, we'll make a loss matrix. Okay. In the loss matrix, what we'll do is we'll negate all the costs. So we have A, B, C, three sources, 1, 2, 3, 4 destination, and we are negating all the values. The supply associated with each resource is 100, 30 and 70, and the demands are 40, 20, 60 and 30. This is the loss matrix. Okay. So first of all we will have to check whether the matrix is balanced or not. So what we do is we calculate the total supply, which is 100 plus 30 plus 70, and the total demand 40 plus 20 plus 60 plus 30, 150. Okay. Now clearly supply is greater than demand and this is not balanced. Okay. So to solve this question we have to first make a balanced matrix. What we'll do is we'll introduce a dummy column. Okay. And the demand of that dummy column will be the difference in the supply and demand, which is 50 here, 200 minus 50, 150. Okay. And the cost of that dummy column will be 0. Okay. So let us, now we've made this balanced matrix by introducing this dummy column. Okay. And we will use VAM algorithm. So in this algorithm we calculate penalties associated with each row and each column. Okay. And to calculate penalty we first find two smallest element of that row or column and we subtract them. Okay. So like in this row we find minus 33 minus 40, which is 7. Okay. Here minus 35 minus 44, which is 9, minus 30 minus 38, which is 8. Here minus 40 minus 44, which is 4. Similarly 3, 2, 3 and 0. Okay. Now after calculating penalties we will find the maximum penalty. So we have 4, 3, 2, 3, 0 and 7, 9, 8. So we have 9 as the maximum penalty. Now with this row we will see which cell is having the minimum element. Okay. So in this row minus 44 is the minimum element, and we will initialize this cell with the minimum of either the supply or the demand left. Okay. So we have 30 or 40, so we can give it 30. Okay. So we have met with the supply of this source, we are left with 0, and here we are left with 10 more units. Okay. So this source's supply is over. Now we will recalculate penalties. It will have no effect here and here. Penalty is 0 here. because the supply is met. The penalty here is because this row is kind of vanished right now. Okay, so we are left with minus 40 minus 38 minus 40. Okay, which is 2 minus 25 minus 38, which is 13, and 6, 3 and 0. Okay, so we have penalties 2, 13, 6, 3, 0, 7, 0, 8. Okay, so we will repeat the above step or previous step. Okay, we will find the maximum penalty, which is 13, and in this column we will find, okay, this row is kind of vanished right now. Okay, we will find the minimum element, which is minus 38 right now. Okay, in this cell we will either give it 20 or 70, whichever is minimum. Here minimum is 20. Okay, we'll give it 20. So we are left with 0 and we are left with 50. Okay, we will this destination's demand is also met. Okay, we will recalculate penalties. So this column is kind of vanished right now, so it will have no effect in these columns. And here we have minus 40 and minus 30, which is 7, no problem, and minus 30 and minus 38, no change. Okay, now again we will see which one is having the maximum penalty. It is 8, this row, and we will find the minimum element, which is minus 38. Okay, and we can either give it 10 or 50. Okay, whichever is minimum, so we will give it 10. Now the demand of this destination is also met, and we are left with 40 units. Okay, now again we will calculate penalties. Will have no effect in here, these columns, and this column are the destination's requirements have been met, so they are kind of vanished. So we are left with minus 22 minus 33, which is 11, and minus 28 minus 30, which is 2. Okay, now the maximum penalty is 11 with this row, and the minimum element is minus 33, because these two are vanished. Okay, so minus 33, we will give it either 30 or 100, whichever is minimum. Minimum is 30, so we will give it 30. Okay, the requirements of this destination is also met, and we are left with 70 units of this source. Okay, again we will recalculate. So this is also vanished. Again we will recalculate the penalties. Will have no effect here and here, and here we have 0 minus 22, which is 22, and 0 minus 28, which is 28. Okay, now the maximum penalty is 28, so we will see this row, and the minimum element is minus 28, so we will give it either the minimum of 40 or 60, which is 40. Okay, this sources supply is also completed, and we are left with 20 more units here. Okay, so this row is also vanished. Now so we have only one row and two columns. Okay, so we can just skip these tabs, and first we'll solve this one. We can give it 20 or 70. Yeah, 20. Now 50 is left, and 50 can be in here. The VAM algorithm is now completed. The new matrix is A, B, C, 1, 2, 3, 4, and dummy. Okay. 30 here, 10, 20, 40, 50, 30, 20. And minus 22 minus 33, 0, minus 25, minus 40, minus 44, minus 35, minus 30, minus 30, 0, minus 38, minus 38, minus 28, minus 30, 0. Now the profit is, you multiply these two. Okay, 30 into minus 44, and you add them all, 20. Okay, now this will come out to be negative. Okay, because you have already converted the matrix into negative form. So the actual profit will be negation of the answer, 20 into minus 22, okay, plus 30 into minus 33, plus 50 into 0 will be 0, and 10 into minus 38, 20 into minus 38, 40 into minus 28. Okay, this comes out to be 5010. I'm leaving the calculations for you. Okay, so this was the initial step, the VAM algorithm. Now we will check the optimal, whether the solution is optimal or not. Okay, we'll make it in the next video. Thank you.